All right, guys, so today we're going to hit 10-5. This is actually a pretty simple lesson. You pretty much learned everything. Because we've already learned how to use the okay? So with that being the case, because what we're doing today is so let's go ahead and start with the matrix equation, which we learned how to put a simple equation into a matrix equation last. Not everybody gets it from the during August. Now, I'm telling you guys, if I had a choice onto solving a system equation, I probably would be doing it a lot. Now, if it was a 3x3, I probably would. A 2x2, it's just too easy just to eliminate it and go at it, right? But if it was a 3x3 or a 4x4, I would do this. When I was taking this in high school and stuff, anything bigger than a 3x3, we got to use our calculator. That's the matrix. So let's write a matrix equation. So with the matrix equation, I have 2, 1, 6, 8, and then xy equals -1, 2. How many guys remember this from the homework on the last lesson? Because what that does is it, watch what happens here. Notice this is a 2x2 and a 2x1. So I am able to multiply them, correct? First row, first column ends up being first row, first column. Okay? So it goes 2 times x, 2x, 6 times y. 6y, I add them together, 2x plus 6y should equal negative. It's just a way to write the matrix. Now, the reason why this happens is I'm going to call this matrix A, this matrix B, and this matrix C. Okay? Now, ladies and gentlemen, how do we want this x, y, don't we? We want to solve for that, don't we? How do I get rid of this matrix? Not half, we times by its inverse. Oh, yeah. And the reason why we times by its inverse is because, let's go on to some history of what we've already learned in previous times. A multiplicative inverse okay, when I multiply two inverses together, such as 3, what's its multiplicative inverse? 1/3. 1/3. It will become my multiplicative identity. And that means if I went 3 times 1, I would get 3, right? Is everybody there with me? We also had an additive identity and an additive inverse. So notice, if I use -3, what's my additive inverse? 3. And notice that gets to my additive, or anyway, identity. Notice, because if I went 3 plus 0, do I get back to 3? So what I also have is a multiplicative identity and a multiplicative, an additive identity for matrices. When I'm adding two matrices together, what do you guys think my additive matrix is? Just a bunch of zeros, right? However many zeros I use. For example, if the matrix was 2x3, for me to add that matrix over, I get the same matrix. Correct? Any questions there? Okay, yes. No, there's no question here. I'm just first off just talking about it. We haven't done any of the question types yet. So an additive identity means if I add a matrix to this, I'd get the exact same thing. Okay? But a multiplicative identity, not every matrix has one. First off, for you to be a multiplicative identity, you have to have a square matrix. You must be a square matrix. So you must be a 1 by 1, a 2 by 2, a 3 by 3, and so on. Okay, that's the only time you'll have a multiplicative identity. Okay? And that's 1. That's 1, 0, 0, 1. 1, 0, 0, 0, 1, 0, 0, 0, 1. And so forth. Basically, that looks like reduced row echelon form, doesn't it? Okay? And let me show you that it works. So let's take a 2 by 2. 2, negative 1, 7, 5. If I multiply that matrix by my identity matrix, am I able to multiply those two? 2 by 2 by 2 by 2? Sure, here we go. 2 by 1, 2. Negative 1 times 0. 2. So first row, first column, 2. First row, second column. 2 times 0, 0, plus negative 1 times 1, negative 1, 7 times 1 is 7, 5 times 0 is 0, that's 7, and that would be 5. Notice, I get the exact same matrix. It's like times by 1. That would be our multiplicative identity for a 2 by 2. Okay? Does that make sense? Okay. So, now, as we noticed with regular multiplication, there was two numbers when I multiplied them together to get that multiplicative identity. Okay? Same thing with matrices. There are two matrices times together, that would give me the identity. Multiplicative identity. Okay, and that's going to be our goal today. What was that matrix A that we originally had in that? All right, so let me show you how you can find your input. 2, 6, 1, 8. Everybody else have this one? Okay, so there's only one off. Hope you're good. So what I'm going to do is I'm going to attach it to the multiplicative identity. Does everybody see that? Yes, ma'am. That is the multiplicative identity. When I'm going to find my inverse, that's always what you're going to do. On a 3 by 3, I'd have the ones down the diagonal, zeros everywhere. If I had a 4 by 4, once again, ones down the diagonal, zeros everywhere. Multiplicative identity. Does that make sense? Okay. So, what we're going, yes. Yes. Well, not always. On the 2 by 2, there's another way, but if it was a 3 by 3 or larger, this is the only way. Answer your question? On a 2 by 2, there is another way, and I'll show you this in a minute. But I'm showing you the hard way. This is the way that most of the time you will be doing it for every other matrix. Everybody good with that? Okay, what do we want here? We want a 1. Well, can I just switch rows? Yes, I can. Okay, now it is important. I do not switch rows before I go ahead and start my matrix. Well, I see how I've already attached it to him. Now I can switch rows. Does that make sense? So right now I'm at 1, 8, 0, 1, 2, 6, 1, 0. Okay, I got my 1 where I want, huh? What's the next thing I want to do? Where that 2 is, I want a 0, right? How do I get that to happen? I multiply row 1 by negative 2. Is everybody good with that? Does it make you feel like doing the first entry over again a little bit? Negative 2, negative 16, 0, negative 2. I go ahead and keep that top row. Negative 2 plus 2. 0. Negative 16 plus 6. 0 plus 1 is 1. Negative 2 plus 0 is negative. Any questions on how I have this one? Okay, I want this to become a what? A 1. So how do I make it become a 1? I divide by negative 10. Okay. That's okay. Fractions aren't bad. You might not think fractions are good, but that's what you have to do. Yes. Basically what I'm doing is making this review row echelon form. So I have my 1, I have my 0, what's this need to be? So I need to divide this whole row by negative 10. Yes. So 1, 8, 0, 1, 0, 1. 1 divided by negative 10 is negative 1/10. 2 divided by negative 10 is 1/5. Anybody questioning so far? Okay, what's our last step? We want that 8 to become a 0. So we're going to multiply the bottom row by negative 8, and I get 0, negative 8. I get 4/5, and I get negative 8/5. Yes, I'm in fractions, and you have to play with them. Do we lose some more bread? The red numbers is the bottom row being multiplied by negative 8. It's to get this guy gone. Watch what's going to happen. 1 plus 0, 1. 8 minus 8. 0 plus 4/5. 1 minus 8/5. Well, 1 is 5/5. You agree? Minus 8/5, which is negative 3/5. And then this guy just still stays the same. So ladies, and gentlemen, what I just did is notice I started off with the multiplicative identity on the right-hand side, right? And I transformed it to the left side. So now this is A's inverse. So this matrix right here is 4/5, negative 1/10, negative 3/5, and 1/5 is A's inverse. Okay? Oh, you're good. So, let me go back up to the original equation. Does somebody have this written out that you can read it to me? Yeah. Okay, so I'm going to go back to my original equation, which was right here, right? This was my original equation. Now, once again, if I times A's inverse by A, isn't that the multiplicative identity? So basically that's getting a 1. So really, what am I left with on that side? X, Y. But when I do to one side, I have to do the other. Now remember, multiplication in matrices is not commutative. So therefore, do you guys see I did it in the front here? I must do it in the front here. So I'm going to take A inverse. Who was A's inverse? 4/5. Negative 3/5. Negative 1 over 10. Is that what A's inverse was when we found it? Okay, and I'm going to multiply that by C. Watch what's happening. This is going to tell us what X was solving. What, where? Right here? Thank you, that would make a big difference. Okay, here we go. So I'm going to take this row to the column. So that's negative 4/5 times plus, so that's negative 4/5, I'll write it down. Plus negative 3/5 times 2 is negative 6/5, which is what? Negative 10/5, which is negative 2. So X is negative 2. Okay, take the next row. Negative 1/10 by negative 1, that's 1/10. 1/5 by 2, that's 2/5, correct? and I'm going to add, so this way, and I'm going to add them, so that's 1/10 plus 4/10, which is 5/10, which is, so x is -2, y is. So it allowed us to solve a matrix equation. Now, to be honest still with you, that would took a lot longer than just, elimination, right? But it's still a cool way to learn how to solve for x. You want to go back and check? Are we all good? So let's go back up into it. So what was our x value? -2, y was 1/2. Here we go. -2 times 2, -4. 1/2 times 3, 6, 3. So -4 plus 3. Okay, I'm going to show you a faster way to find the inverse of a 2 by 2. That was the long way. I'm going to show you the quick way. Now, the way I just showed you, though, is how you're going to do it for most of your homework. I would say 3/4 your homework. Anything other than a 2 by 2, this is the best. And we'll do a 3 by 2. Okay, does that make sense? Yeah. But on a 2 by 2, there is a different way. Let's say we had matrix A, B, C, D. Okay. If I had such matrix, to find its inverse, we'll call him A. A's inverse would be 1/AD minus BC times by matrix DA -B -C. That'll make the same thing you've had in your head. And I'll be honest, I remember this after 5 years of doing it. I was so proud. Okay. So what was that matrix that we originally had for A? Yeah. A was who again? Everybody agree with that? Okay. So we're going to do it quicker this time and find its inverse. This should be the same inverse we had, right? So here we go. 1/AD, so AD would be 16 minus BC. So that's 1/10. And then notice, do this, flip it. So this is 8, this is 2, this is -6. Okay, all I did, notice this was A, B, C, D, right? So I switched A and B. Okay, and did the opposite here. Okay, now I'm going to distribute that through 1/10 times 8, 8/10, which is 4/5. 1/10 times -6, -6/10, which is -3/5. 1/10 times -1, and 1/10 times 2. Did we get out the same? Now, me personally, I'd rather do this than the other way. Do you agree? Yeah.
So why can't we always use it?
You can do it every time on that. But the reason why I showed you the other way is this only works for 2 by 2. So if I had a 3 by 3, well, I have to do it. So I was just preparing you that way works for everyone, every single square matrix, whereas this one only works for 2 by 2. Answer your question?
Yeah.
So on your test, if they ask you for the inverse on 2 by 2, am I okay with that? No. But understand, the other way works every matrix that has an inverse. Because not every matrix has an inverse. Because once again, if I was a 2 by 3, would I have an inverse?
how we
Has to be a square matrix here. Okay? And then, once again, think about that. Does every matrix have a solution? Every system of equations? No, we have things that have no solution. So if you didn't have an inverse, no, your bottom row would just come out and go 0, 0, 0, 0. Does that make sense? Yeah. So if it's not a square matrix, you understand, boom, it's not there. And then if it is a square matrix, just go for it, and then you might see that. Hey, I might be in your accelerating class as your teacher.
Really? That'd be so fun.
I really don't. I don't think the afternoon kids would do freaking on the movie. Okay. Notice, still have the inverse though. That was our goal. And so then when I have the inverse, I could times it by a to both sides, and that's solve this. Yes. Yeah, has to be a square matrix. No, they don't have one. We was going pretty quick. I've started to swipe more. I kind of like it. My thumb's starting to hurt, so I started doing swiping. Samsung 8 active. No, you cannot. You got such fat fingers. Okay, we ready for our next one? Are we gonna do a 3 by 3? Okay. So we're gonna do a 3 by 3 now. We'll solve it. Okay. Okay, so here's our system of equations. Now, understand, he might ask you to do it different ways. Let me explain the different ways on the test he could ask you. Please solve for x, y, and z using Gauss coordination. Now, it's just by doing row. He could ask you to say, please solve the system of equations by doing Gauss coordination. That's reduced row echelon. He could ask you to solve this via a matrix equation. That's what we're doing today. Matrix equation is today. Okay? Does that make sense? The other way is to solve the system of equations with the Cramer's rule, which is what we're doing tomorrow. Okay? So there's 4 ways to ask the same question. Okay? So this one's going to be a matrix equation. So I set up a matrix equation where this is 1, -2, -4, 2, -3, -6, -3, 6, 16. X, Y, Z equals 7, 5, 0. So once again, I'm going to call this matrix A. Matrix B, matrix C. I want to solve for matrix B, right? How do I get B by himself? I times by what? A's inverse to both sides. So B is the same thing as A's inverse times C. Agree? For me, it's an economy of what? Not done this for Abby Peterson and all her building. Abby. We're gonna say that. Oh, oh, no. All right. So now, guys, we're going to go ahead and set up the inverse, though, because that's what I need is A's inverse, huh, for this equation, correct? So I have 1, -2, -1, -4, -2, -3, -6, -3, 6, 15. Once again, who are we going to attach it to? We're going to do its identitive matrix. This is a 3 by 3, so I have 1, 0, 0, 0, 1, 0, 0, 0, 1. Did you ever understand why I'm attaching it to the identity matrix? So basically, we have the identity matrix on the right, and now we're going to make it to the left by doing reduced row echelon form. Very much similar to the first day we did 10-3, right? Just another way to do it. If you would like to, you don't even have to check it, but maybe it's just easier for you to see a mistake. Okay, you guys ready to rock? We got a 1. Okay. I'm going to do where that 2 is, what do I want him to be? A 0. And where that 3 is, I want him to be a 0 as well. I'm going to do 2 steps in one. Is that okay with you guys? Because I'm going to times this top row by what to get rid of him? A -2, right? Good thing. So this would be -2, 4, 8, -2, 0, 0. How do I get rid of this -3? I taught times row 1 by how much? It's just regular old 3, right? And notice 1 times 3 is 3, -6, -12, 3, 0, 0. So I keep the top row. Any questions there? Yes. Yes, ma'am. Because whenever I want to eliminate and put zeros in these locations, I always use the top. If I want to use the middle, I'm going to use the second. Answer your question? Here we go. -2 plus 2. 0, and that's what we wanted to happen, wasn't it? 4 plus -3. 1. Oh, that's nice. They already gave us the one where we wanted. 8 minus 6. -2 plus 0. 0 plus 1. 0 plus 0. Okay? Let's add this black one I have right here plus row 3. -3 plus 0 is 0. 6 minus 6 is 0. Oh my goodness, it's like way too many. -6, excuse me, 15 and 12. -12 is 3. 0 plus 3 is 3. 0, 0 is 0. 1, 0 is 1. Guys, look at that. In basically 2 moves, I've got what I almost want down our diagonal building. What do we now want? I want one where that 3 is, right? So therefore I have 1, -2, -4, 0, 1, 2, 0. I should have these out. 1, 0, 0, -2, 1, 0. Dividing everything, so 0 divided by 3, 0. 0 divided by 3, 0. 3 divided by 3, 1. 3 divided by 1, 3, 1. 0 and 1/3. Yes, no, maybe so. Alice, what are we going to do next? No.
Oh, it meant to make it.
I need to make it reduce row echelon. The third row by -2 and add it to the second row. Because what happens if I ever want to get anything out of the third column, I have to use the third row. So therefore, when I multiply this by -2, I get 0, 0, -2, -2, -2 thirds. Yes, no? We're good? Okay, so keep in row 1.
You like how it's called, because I was good at how
No problem. So your steps are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Unless he tells me to solve, or Gaussian. Well, unless he tells you, and so therefore I'm keeping the top two rows, right? So, excuse me, top row and the bottom row. So 1, -2, -4, 1, 0, 0. 0 plus 0 is 0. 0 plus 1 is 1. That's why it's important to use the bottom row so that when I add those together, he's still 1. Does that make sense? 2 minus 2 is 0. -2 minus 2 is -4. There's a 0 here, I apologize. 1 plus 0 is 1. 0 minus 2/3 is -2/3. Okay. Any questions there? Allie, good. Either of you. She was looking at me, so I went with it. Okay, are we done? What do we want to do next? Where that -4 is, I want him to be a 0, right? So because that's in column 3, which row am I going to use to help us solve it? Row 3. Because this is the 1. This is the one. If I use 2, I can't get rid of 0. So I'm going to use this. I'm going to times it by 4. 0, 0, 4, 4, 4, third. Here we go. Row 1. 1 plus 0 is 1. -2 plus 0 is -2. -4 plus 4 is 0, which we want it, right? 1 plus 4 is 5. 0 plus 0 is 0. 0 plus 4/3 is 4/3. Then I keep him. Keep him. You see how there's lots of opportunities for mistakes though? Right? Are you a jewel thief right now? Okay, last step. What's our last step? So what row am I going to use? Row 2, because I'm in column 2. If I'm in column 2, I use row 2. If I'm in column 1, I use row 1. Okay? So I'm going to times it by 2. So 0, 2, 0, -8, 2, -4/3. So here's what we get. 1 plus 0 is 1. -2 plus 2 is 0. 0 plus 0 is 0. 5 minus 8 is -3. 0 plus 2 is 2. 4/3 minus 4/3 is 0. And I have this. Okay? We are done, aren't we? So therefore, this is who? A's inverse. So A's inverse is -3, 2, 0, -4, 1, -2/3, 1, 0, 4. That is A's inverse. A little bit of pain in the butt. Luckily, you guys only have 12 homework problems today. So it's not a lot. It's going to ask you some of them just to find the inverse, and then on some ones it's going to ask you to solve the inverse. So you're going to have to find the inverse. Okay? Then we're going to solve. Yes. What? Say again. I don't know. I have to look.
Oh, wait, yeah.
1/3. Oh, yep. Should be 1/3. Thank you. No, that's just a very quick mistake. Huh? No, and I know it happened, so, you know. Okay, so, now let's go back to this equation. Where's that equation? Did I move it up here? It's right there, right? So we want to take matrix A inverse, because remember, ours was B equals A inverse times C, right? We just had A inverse, who is that? Let's write it down. It was -3, 2, 0. Okay, so there's A's inverse. Does everybody agree on A's inverse? What is the next thing I'm looking for? Well, I'm looking for C, and what was C? 750, correct? So when I multiply these, I will get what XYZ was. Because that was matrix B, correct? You guys ready? First row, first column. -3 times 7 is -21. Plus 10 plus 0, so -21 plus 10 is -11. So x is -11. -4 times 7 is -28. Plus 5 plus 0. So therefore -23. 1 times 7 is 7. 0, 0. So this is so x is -11. Y is -3. Z is 7. Okay? You need this.
Well, so we do the top line for
Well, no, because this is, remember, how do we just multiply? Rows by columns, right? So this is a 3 by 3. This is a 3 by 1. And we multiply that.
Yeah.
Yes, because the inside equal. And what is it? And then going to be a result? 3 by 1. And if that matrix is 3 by 1 and this matrix is 3 by 1, then they're final x. Does that answer your question? Okay. Should I go plug them back in and see if it works? Ladies and gentlemen, that's it in a nutshell. You want me to keep going or you want to try to do some work? Anybody else? Okay, so your homework is, make sure. Okay.